Thank you for watching this video. I am the person who previously created the Windows 10 powered electronic dictionary. In this video, I will introduce the process of a college student independently building resin-based 3D printer. Building a 3D printer required diverse developments such as designing the casing using 3D CAD, designing electronic circuits, producing custom parts by purchasing machine tools, and developing software. Additionally, I improved the shortcomings of existing 3D printers through the development of original methods. I faced many struggles until completion, but I somehow managed to finish it. This video series consists of 4 parts, and part 1 covers the above content. First, please watch the CG animation of the 3D printer created for this project.
Did you see, did you hear, did you feel anything in the world you're in the world you're in? Brutality, make it 1, make it 2, make it 3 times around. And they're suffering, yeah. Counting down, tick-tock, and the time is running out. No first, let's take it. We'll save your head now, no. Crashing down, no money that can buy your way out. Go ahead and try it, 'cause you've had your time. Playing God, playing God. We're counting down, tick-tock, and the time is running out. No first class ticket. Where have you been? Did you see, did you hear, did you feel anything in the world you're in the world you're in? Brutality, make it 1, make it 2, make it 3 times around. And the suffering, they're suffering.
Though it seems cool, the reason behind the creation was, in fact, rather trivial. The idea for creating a 3D printer originated from a certain frustration. He graduated from high school and entered university. However, it didn't take long for problems to plague him. Yes, he couldn't make any friends. Being smart, he thought and thoroughly researched online how to make friends. He arrived at a certain saying. It is, you should not be passive in making friends. Instead, you should proactively create them. Upon finding this saying, he had an idea.
If I proactively create a 3D printer, wouldn't the friends I make using that 3D printer be proactive friends?
Friends should be made by oneself. He interpreted this literally and came up with the idea of outputting friends using a 3D printer. Yes, he was complicate things. Creating his own 3D printer was also his own way of capturing proactive. Thus, the development of the 3D printer was started by him, who went out of control. Over the course of more than 3 years. End of the story will be introduced again when the 3D printer is completed.
First, let us introduce the features of the 3D printer I have decided to produce. Simply creating the same thing as a commercially available product would be boring, so unique innovations were applied. These unique innovations are designed to address the common issues of typical resin-based 3D printers using LCD technology. I will introduce our original innovations along with the mechanism of a general resin-based 3D printer. General resin-based 3D printers using LCD technology utilize a transparent and LCD for fabrication. For example, consider a transparent LCD that displays the word test, as shown in the diagram. Only the parts forming the letters test allow UV light from the UV light source to pass through. Therefore, the UV curable resin on top of the transparent LCD is thinly cured in the shape of test. In other words, by changing the display content on the transparent LCD, resin can be thinly cured in arbitrary shapes. By stacking the thin cured layers produced by this curing process, it is possible to fabricate arbitrary 3D objects. However, in this mechanism, the maximum cross-sectional size of the fabricated object is restricted by the size of the transparent LCD. In other words, with conventional mechanisms, producing large objects requires large transparent LCD. However, there are several disadvantages to enlarging the transparent LCD. Firstly, enlarging the LCD at the same resolution decreases pixel density per unit area. Secondly, the larger and higher resolution the transparent LCD, the more expensive it becomes. In summary, maintaining fabrication precision while enlarging the maximum fabrication size incurs significant costs. To address this, the 3D printer I created incorporates a method that balances fabrication precision and maximum fabrication size while being affordable. The mechanism is extremely simple. If enlarging the transparent LCD is not feasible, making the transparent LCD movable solves the problem. This way, the size of the modeling can be increased while the resolution is increased by moving the transmisic LCD. From now on, let's call this mechanism the MLCD method. I decided to use this method because it offers high resolution and a wide molding range at a low cost. Moreover, commercially available 3D printers have issues with expandability, such as being unable to add functions like resin auto-loading or replace the LCD designated as consumables with higher resolution ones. The problem of not being able to add functions after purchase has been addressed with expansion ports for expansion modules. The issue of being limited to using specific transparent LCD was resolved by physically separating the display control circuit from the main board of the 3D printer, making it possible to replace the display control circuit. Incorporating the unique innovations mentioned earlier, the goals for producing the 3D printer were as follows. Realizing the MLCD method refers to incorporating a mechanism that moves the transparent LCD. Achieving a user-friendly UI means efficiently designing the interface screen, motion, and function arrangement. Designing with aesthetics in mind refers to emphasizing not only functionality, but also an attractive appearance for the design. To support wireless communication means to be able to receive print data and perform remote control via wireless. While it's easy to set goals, numerous technical barriers existed for someone as inexperienced as me. In the next chapter, I will introduce required technologies for production and rough casing design using 3D CAD. A production like this one can be roughly divided into hardware production and software production. In hardware production, tasks like casing design, PCB design, and manufacturing need to be performed. As for casing design, I had already mastered 3D CAD, so it was feasible, but for PCB design using PCB CAD and metalworking for manufacturing, I needed to learn from scratch. Similarly, software production requires tasks such as creating UI design, creating programs using OpenGL, and creating programs for embedded Linux. Although I had some experience with programming, I had no experience with software development using OpenGL or embedded Linux development, so I had to learn these from scratch as well. It is insane to think now that I decided to produce the project despite such a lack of knowledge, but I learned what I lacked each time through the production process. Let's now introduce rough casing design using 3D CAD. Since this is a rough design, I mainly design the exterior and the framework of the casing rather than designing the internal structure. Creating something from scratch is challenging, so I began by lightly sketching the casing design. Next, I reproduced on 3D CAD only the external appearance from the sketch, in a size that would roughly accommodate the functions and mechanisms. Based on the 3D CAD data of just the exterior appearance, I designed the internal frame structure. Considering body rigidity as an important element, I adopted a framework shape that performed well in structural calculations. For frame materials, I determined that aluminum frames were optimal due to their strength, ease of assembly, and cost. Next, I added panels to the aluminum frame to match the initially designed appearance. Panel fixation on the exterior was done using screws to ensure removability for maintenance. And the panel fixing screws are laid out in a position where they cannot be seen from the exterior by means of a hooked structure, thereby ensuring aesthetic appeal. Finally, the rough design of the casing will be completed once the acrylic plates are combined to design the top cover. The orangish color scheme of the top cover is designed to block external light with the wavelengths that harden UV resin. In other words, the cover prevents the UV resin from curing due to sunlight or other factors. Thus, the basic appearance and frame structure of a casing were decided. Thank you for watching Part 1. Part 2 will be posted in 3 days. If you found this interesting, please subscribe to the channel to receive notifications when Part 2 is posted. Also, I would be happy if as many people as possible could see it, so I would appreciate it if you could share it on social media such as X. Finally, if anyone has anything they would like to tell me directly, please feel free to DM me on X.